All right, here is the second video on 1.10, section 1.10 on inequalities. Okay, so let's look at solving linear equalities, and then the second part here is solving absolute value inequalities. So solving linear equalities, so they have this little thing over here on the side, just to remind you with inequalities, when you multiply or divide by negative, you're going to flip the inequality symbol. And what I mean by that is if you have this, you multiply by or multiply or divide by negative, it's now going to point in the other direction. Okay, so multiplying or dividing by negative, you switch the sign to point the other way. Okay, so let's take a look at a couple of these. I'll do number 8 and number 11, then we'll take a look at some absolute value inequalities. And then that will be all for this video. Okay, so solving inequalities, especially, let's see, this looks like a simple one here. Are these all simple inequalities? Yeah, there's no compound. It's very much like solving an equation. The only thing you have to really pay attention for is if you multiply or divide by negative, your sign switches. Other than that, all of the rules are pretty much the same. So if we were looking at this like an equality, like an equation, first we would distribute here, right? So let's do negative 12x plus 6 minus 4x is less than negative 90. So I just distributed this negative 3. Let's combine like terms on the left side. Negative 12x minus 4x would be negative 16x plus 6 is less than negative 90. Let's subtract 6 from both sides. So we have negative 16x is less than negative 96. Okay, divide by negative 16 to get x by itself. We get x is greater than, right, because we're flipping signs here because we divided by negative. So x is now greater than whatever this is. I'm guessing it's a whole number. 96 divided by 16 is 6. So x is greater than 6, okay? So let's graph this. We're going to do an open circle over 6. We're going in the greater direction to all the bigger numbers, so our arrow is going to point right. Just for extra practice here, so this is our solution set as an inequality. If we were to write this in set builder notation, we would say all values of x such that x is greater than 6, close bracket. And then in interval notation, our lower bound is 6. It's not included, so it gets parentheses to infinity. And this would be our solution set written 3 different ways here. Oh, the instructions tell you to write in both set and interval notation. Okay. So that's that one. Like I said, these are just going, I'm just looking at 9 and 10. These look like you're just going to solve them like you would solve an equation. So I'm actually not going to spend any more time on these because they look fairly straightforward. So just remember, when you multiply by negative, let's highlight this guy over here. When you multiply or divide by negative, flip the inequality. Okay, so don't forget that. All right, so let's move on to solving absolute value inequalities. So absolute value inequalities are a special type of inequality because they're always going to be a compound inequality, okay? So depending on which way the sign is facing, that's going to determine whether it's going to be an and compound inequality or an or compound inequality. Okay, so hopefully let's talk about a little bit about why it becomes a compound inequality. So let's look at these steps here. To solve an absolute value inequality, isolate the absolute value, create 2 cases, and then solve both cases. Okay, so we have step number 1, isolate the absolute value. In number 12, the absolute value is already isolated. Okay, so we can move on to step 2 here. Create two cases. So what these two cases would look like is very similar to when we solve absolute value equations, right? We're going to write the other side, we're going to have a positive version and a negative version, but with these inequalities, we are going to flip the sign when it becomes negative. Okay, so we're going to write these in two different cases here. We'll write what's inside the absolute value, so 5 minus 10a. Let me zoom back in here. 5 minus 10a is greater than 15. And then our other inequality will be 5 minus 10a is less than, so we're flipping the sign here and writing negative 15. Okay, so here we're going to solve each of these inequalities separately, and then we're going to see what our solution sets will be. So 5 minus 10a, we're going to subtract 5 from both sides. We'll have 10a is greater than 10, and then dividing by negative 10, we're going to get a. Flip the sign is less than negative 1 here. Okay, so there's 1. So let's graph this one here. Negative 1, we're going to have an open circle above. We're going in the negative direction like this. Okay, and then solving this other side, we'll subtract by 5 here, so negative 10a is less than negative 20, and then dividing by negative 10, we get a is greater than, flipping the sign here, 2. So then we have above 2, also an open circle, going in the right direction here. And so you can see from here that we actually have an OR case. So our solution as an inequality will be a is less than negative 1 or a is greater than 2. Writing it in set builder notation, all values of x such that, let's back up here, all values of a, because that's our variable now, such that a is less than negative 1 or a is greater than 2. Okay, and then writing this in interval notation, we'll take the lower interval first, so negative infinity to negative 1, both parentheses, union 2 to infinity, also both parentheses. So here are our solution sets written as an inequality in set builder notation and an interval notation. Just want to make sure this was x up there. Okay, yeah. Good, okay. So let's do another kind here, and then we'll talk about kind of like a quick trick, I suppose, for determining right off the bat whether you're going to have an and or an or. Okay, so let's look at number 14. I forgot to even talk about the third step. Solve both cases. Okay, so if we look at number 14, first is to isolate the absolute value, then create two cases and solve for both cases. So here, isolating the absolute value means getting rid of this negative 4 that's being added. So, or that's being technically subtracted, I guess. So let's subtract let's add negative 4, add 4 to both sides. Then we have the absolute value of x minus 3 is less than or equal to 4. Okay, absolute value is now isolated, so we'll separate this into two conditions here. We'll write what's inside the absolute value, brackets, x minus 3 is less than or equal to 4, and then x minus 3 is greater than or equal to negative 4. So remember, when we write out these two separate situations, that's how we can get rid of the absolute value brackets. So when it's just combined as one, when it's just like one inequality up here, you have to leave the absolute brackets. But as soon as you can split them apart into two different ones, the absolute value brackets go away. So that's how you can keep track of that. And then when we wrote the negative version over here, we flipped the sign. Okay? So let's solve each of these individually. So we're just going to add 3. So x is less than or equal to 7 on one side, and then we have x is greater than or equal to negative 7. No, negative 1. Negative 4 plus 3 is negative 1. So graphing these, let's look at this left one. X is less than or equal to 7. So 7 is going to have a closed circle on it. It's going to go in the left direction forever. And then x is greater than or equal to negative 1. Negative 1 will have a closed circle, and it's going to be going in the right direction forever. Okay, but because these have to these overlap here, this is going to be an and inequality. Okay, it has to be both less than 7 and greater than negative 1, as you can see by the graph here. So let's write this in set builder notation. We have all values of x such that negative 1 is less than or equal to x, which is less than or equal to 7. Okay, remember when you have the and type of compound inequalities, you can write the two conditions as one statement. And then our interval notation, both bounds are included, so we'll have negative 1 to 7 with brackets. Okay, so here is our solution set written 3 different ways and then graphed. Okay, so looking at this really quickly, there's a little trick where you can see right away whether you're going to have an and compound inequality or an or compound inequality. Okay, so once you get down to isolating the absolute value, if the side of the absolute value where your variable is greater than the solution, it's going to be an or compound. And this isn't super important, so if you don't remember this, that's fine. But in case you wanted to know. So that's going to be an or compound. If the side of your absolute value, the side of your variable, once it's isolated, is less than the solution, it's going to be an and type. Okay, so you can kind of see beforehand what type of compound inequality you're going to have. But anyway, so this is just like solving regular inequalities, kind of mixed in with how we solve absolute value equations. Kind of just use the same techniques from both to solve absolute value inequalities. Okay, so we'll put this formative up for you to practice the rest of these, and then